Ever dreamed of traveling to distant stars, reaching them in the blink of an eye? What if I told you that science might finally have a breakthrough that could make this dream a reality? Today, we're diving into an incredible discovery that promises a way to travel 10 times faster than light. Buckle up, because this is not your typical science fiction story. It's something that could redefine our entire understanding of space and time. So get ready to explore the science that could one day take us beyond the limits of our universe. For decades, the speed of light has been considered the ultimate speed limit of the universe. According to Einstein's theory of relativity, nothing can travel faster than 299,792,458 meters per second. This speed limit means that even our closest interstellar neighbor, Proxima Centauri, would take over 4 years to reach, assuming we could travel at the speed of light, which we currently can't. This limitation has made interstellar travel seem like a distant dream, something confined to science fiction movies. But recent scientific advancements are challenging this fundamental rule and suggesting a way to break this universal speed limit. Imagine a spacecraft that doesn't just move through space, but bends it. The concept of warp drive, first introduced by physicist Miguel Alcubierre, suggests that by creating a warp bubble, we could compress space in front of the ship and expand it behind. This would theoretically allow the spacecraft to travel faster than light without actually violating the laws of physics. For years, this idea remained purely theoretical, but recent experiments and simulations have shown that such a warp bubble might be possible. Scientists are now exploring the materials and energy requirements needed to create this bubble, bringing us closer to turning this sci-fi concept into reality. Quantum tunneling is another fascinating phenomenon that could revolutionize space travel. It allows particles to pass through barriers instantaneously, a kind of quantum shortcut through space. While this doesn't apply directly to large objects like spacecraft, recent research has shown that under certain conditions, information, and even small particles could effectively teleport across vast distances. By harnessing these principles, some scientists believe we might one day be able to send probes or signals across the universe at speeds far exceeding light. Imagine sending a probe to another galaxy in a matter of seconds. One of the more exotic theories involves the use of negative mass, a hypothetical form of matter that would have properties opposite to normal matter. If such a substance exists, it could create a propulsion system that defies our current understanding of physics, allowing for faster than light travel. Recent experiments have simulated conditions where negative mass-like behavior was observed, sparking excitement and debate among physicists. While we're still far from building a spaceship powered by negative mass, the possibility alone is enough to stir imaginations and fuel further research. Dark energy, the mysterious force that is causing the universe to expand at an accelerated rate, could hold the key to faster than light travel. Some theories suggest that by manipulating dark energy, we could create a propulsion system that enables us to travel across the cosmos at unimaginable speeds. While this is highly speculative, it's a tantalizing possibility. Researchers are currently studying the nature of dark energy, trying to understand its properties and potential uses. If we can figure out how to harness this force, it could open up a whole new realm of possibilities for space exploration. Wormholes have been a staple in science fiction for decades, but could they become a reality? These hypothetical tunnels through space-time could, in theory, connect distant parts of the universe, allowing for instantaneous travel from one point to another. Imagine stepping into a spacecraft, entering a wormhole near Earth, and emerging light years away in an instant. While the concept is still largely theoretical, some physicists believe that under the right conditions, wormholes could be stabilized and used for travel. Researchers are now exploring the potential for creating or discovering naturally occurring wormholes and figuring out how to safely navigate through them. For many of these futuristic propulsion methods, one of the biggest hurdles is the need for exotic matter substances that don't behave like anything we currently know. This could include negative mass, strange forms of energy, or even entirely new states of matter. Scientists are investigating whether such exotic materials could exist and how they could be produced or harnessed. If we can find or create these materials, they could open the door to technologies like stable wormholes or warp drives. But until then, it's a tantalizing puzzle that researchers are eager to solve. The Casimir effect, a phenomenon predicted by quantum field theory, involves the attraction between two closely spaced plates in a vacuum. This effect could potentially be harnessed to generate a form of propulsion. If scientists can figure out how to manipulate the Casimir effect on a larger scale, it could create a new type of engine that leverages quantum forces to propel a spacecraft faster than light. While this idea is still in its infancy, it highlights the potential of quantum mechanics to revolutionize space travel. Some theoretical physicists suggest that our universe might have more than the three spatial dimensions we're familiar with. If higher dimensions exist, they could offer shortcuts across vast distances, similar to a wormhole. By navigating through these extra dimensions, a spacecraft could travel faster than light without violating the known laws of physics. This concept, while purely speculative at the moment, is being explored in theories like string theory and M theory, which seek to describe the fundamental nature of the universe. If proven, it could open up unprecedented possibilities for interstellar travel. Gravity waves, ripples in the fabric of spacetime, were only recently directly detected, but they could hold the key to new propulsion methods. Some scientists speculate that by generating and controlling artificial gravity waves, we could warp spacetime around a spacecraft, creating a kind of surfboard effect that propels it faster than light. This would be similar to the concept of a warp drive, but using gravitational waves instead of a warp bubble. Research is still in the very early stages, but this could become a fascinating area of future study. What if we could build a spacecraft molecule by molecule, designed to withstand the extreme conditions of faster-than-light travel? Nanotechnology could make this possible. By manipulating materials at the atomic level, we could create super-strong, ultralight materials that can handle the stresses of high-speed travel. This would allow us to build spacecraft capable of withstanding the immense forces involved in faster-than-light travel. While we're still a long way from this level of technological sophistication, advances in nanotechnology are bringing us closer every day. Photon drives, which use light itself as a propulsion method, have been proposed as a way to achieve incredible speeds. By emitting streams of photons, a spacecraft could theoretically accelerate to a significant fraction of the speed of light. While this wouldn't technically surpass the speed of light, it could get us close enough to make interstellar travel feasible. Advances in laser technology and material science are making this a more realistic possibility, and some experimental prototypes are already being developed. One of the biggest challenges of faster-than-light travel is carrying enough fuel for the journey. The concept of an interstellar ramjet, first proposed by physicist Robert Bussard, suggests that a spacecraft could collect hydrogen from the interstellar medium and use it as fuel. This would allow the spacecraft to accelerate indefinitely without needing to carry its own fuel. While there are still many technical challenges to overcome, this concept could potentially solve one of the biggest hurdles to interstellar travel. Antimatter, the opposite of normal matter, releases enormous amounts of energy when it comes into contact with matter. This makes it an incredibly efficient fuel source. Just a few grams of antimatter could power a spacecraft for years. Creating and storing antimatter is extremely challenging, but advances in particle physics are bringing us closer to this goal. If we can find a way to produce and harness antimatter safely, it could enable spacecraft to achieve speeds far beyond anything currently possible. Dark matter makes up about 85% of the mass of the universe, yet we know almost nothing about it. Some researchers believe that dark matter could be used as a propulsion method if we could figure out how to interact with it. This is a highly speculative idea, but it's not entirely out of the realm of possibility. If we could tap into the vast reservoirs of dark matter that permeate the universe, it could provide a nearly limitless energy source for faster-than-light travel. Magnetic fields are already used in some propulsion systems, like ion thrusters, but they could also be used to achieve faster than light speeds. By creating powerful magnetic fields around a spacecraft, it might be possible to create a kind of magnetic sail that pushes against the fabric of space-time itself. This concept is still very theoretical, but experiments with magnetic propulsion are showing promise. If we can figure out how to generate and control these fields effectively, it could lead to a new kind of propulsion system. Cold fusion, a form of nuclear reaction that occurs at or near room temperature, has been a controversial topic for decades. If it can be made to work, it would provide a virtually limitless and clean energy source. This could be used to power spacecraft on long interstellar journeys, possibly even enabling faster-than-light travel. While most scientists remain skeptical, recent experiments have shown some intriguing results, suggesting that cold fusion might one day become a reality. Plasma propulsion systems, which use ionized gas to generate thrust, are already being tested for use in space travel. These engines can provide continuous acceleration over long periods, allowing a spacecraft to reach high speeds. While current plasma engines are not capable of achieving faster-than-light speeds, advancements in this technology could one day make it possible. Researchers are exploring ways to increase the efficiency and power of plasma engines, making them a promising option for future interstellar travel. What if instead of changing our spacecraft, we changed ourselves? Some scientists are exploring the idea of using biotechnology to adapt the human body for the extreme conditions of space travel. This could include everything from genetic modifications to enhanced radiation resistance, to developing ways to put humans into a state of hibernation for long journeys. While this wouldn't directly enable faster-than-light travel, it could make it more feasible for humans to undertake long interstellar voyages. Artificial intelligence is already transforming our world, and it could play a crucial role in faster-than-light travel. Advanced AI systems could help us navigate through the complex and uncharted territories of space-time, making real-time adjustments to the spacecraft's course and propulsion system. AI could also assist in finding the most efficient pathways through space, perhaps even discovering shortcuts or new methods of travel that humans haven't yet imagined. As AI continues to evolve, it will likely be a key player in the future of space exploration. Space elevators are a concept that could revolutionize how we launch spacecraft into orbit and beyond. By building a tether from the Earth's surface to a point in space, we could lift payloads into orbit without the need for traditional rocket propulsion. This would dramatically reduce the cost and energy required for space travel, making interstellar missions more feasible. While there are significant engineering challenges to overcome, the idea is gaining traction, and if realized, it could provide a launching point for faster-than-light exploration. Solar sails are a promising technology that uses sunlight to propel spacecraft. By capturing the momentum of photons, a solar sail could gradually accelerate over long distances. While this method wouldn't achieve faster-than-light travel on its own, it could serve as a stepping stone, allowing us to reach significant fractions of the speed of light. Ongoing missions, like the Planetary Society's Light Sail, are testing these concepts, paving the way for future interstellar missions that could incorporate faster-than-light technologies. As we develop faster-than-light travel, understanding the biology of life beyond Earth becomes essential. Astrobiology explores the potential for life on other planets and how we might adapt human biology for different environments. Research in this field could provide insights into how we could survive long journeys through space, potentially paving the way for colonization of distant worlds. Understanding the limits of human physiology will be critical for ensuring the success of any interstellar missions. One of the fascinating implications of traveling close to the speed of light is time dilation. According to Einstein's theory of relativity, time moves slower for those traveling at high speeds compared to those who remain stationary. This means that astronauts on a faster-than-light journey might experience only a few years of travel time, while decades could pass on Earth. Understanding the effects of time dilation will be crucial for planning interstellar missions and ensuring that the travelers can reintegrate into society upon their return. The ability to travel faster than light would not only transform science and technology, but also have profound cultural implications. It could inspire a new era of exploration, fostering a sense of unity among humanity as we become a multi-planetary species. This shift could change our perspective on Earth, urging us to work together to protect our home planet. Additionally, it would raise philosophical questions about our place in the universe and the potential for encountering intelligent life beyond our solar system. With the possibility of faster-than-light travel on the horizon, we could see a new space race, not just between nations, but also involving private enterprises. This competition could lead to a surge of investment and innovation in space technology, creating jobs and economic opportunities on Earth. As companies seek to develop the next generation of spacecraft and propulsion systems, the potential for a booming space economy could drive advancements in a wide range of fields, from engineering to materials science. Faster-than-light travel will likely require collaboration on an unprecedented scale. Nations around the world will need to pool their resources, knowledge, and expertise to tackle the immense challenges involved in this endeavor. International partnerships could lead to shared research facilities, joint missions, and the development of universal standards for space exploration. By working together, humanity can overcome the barriers to interstellar travel and unlock the mysteries of the universe. For faster-than-light travel to become a reality, we need to inspire future generations to pursue careers in science, technology, engineering, and mathematics, STEM. Educational programs and public outreach initiatives can play a vital role in fostering interest in space exploration. By engaging young minds with the possibilities of interstellar travel, we can cultivate the next generation of scientists and engineers who will ultimately make this dream a reality. As we push the boundaries of space travel, we must also consider the ethical implications of our actions. The potential for encountering extraterrestrial life raises questions about our responsibilities as explorers. How do we approach other civilizations? What are the ethical considerations of colonizing other planets? Engaging in these discussions now will help us navigate the moral landscape of future interstellar endeavors, ensuring that we approach our explorations with care and respect. As we venture into the unknown realms of space, simulations will play a critical role in preparing for interstellar travel. Advanced computer models can help us predict the behaviors of spacecraft in various scenarios, from navigating through wormholes to dealing with the challenges of time dilation. By simulating these conditions, scientists can test theories and refine technologies before embarking on real missions, ultimately increasing the chances of success in our quest for faster-than-light travel. The quest for faster-than-light travel has already spurred numerous innovations in propulsion technology. From ion thrusters to nuclear thermal engines, each advancement brings us closer to realizing our interstellar dreams. Researchers are constantly exploring new materials, energy sources, and designs to improve the efficiency and effectiveness of spacecraft propulsion systems. The innovations developed in this pursuit may also have applications here on Earth, improving transportation and energy use in our daily lives. As we develop the technologies for faster-than-light travel, the potential for space tourism could expand dramatically. Imagine visiting distant planets or even other star systems as part of a luxury vacation. This new frontier in travel could redefine the way we experience the universe and foster a greater appreciation for the cosmos. As commercial enterprises look to capitalize on this opportunity, we may see a new era of adventure and exploration open up for everyday people. Faster-than-light travel could significantly enhance our ability to search for extraterrestrial intelligence, SETI. With the ability to reach distant star systems in a fraction of the time it currently takes, we could conduct more comprehensive surveys of potentially habitable planets. If we do encounter intelligent life, the implications could be profound, leading to new understandings of life, technology, and the universe itself. This search is not just about finding others. It's about understanding our place in the cosmos. As we prepare for faster-than-light travel, we must also consider the legal frameworks that will govern our activities in space. Existing space law, based on treaties like the Outer Space Treaty, may need to be reevaluated to account for new technologies and the potential for colonization. Establishing clear regulations and agreements will be essential for peaceful exploration and cooperation among nations. Legal scholars and policymakers will play a crucial role in shaping the future of space law as we embark on this new frontier. As we look to explore the universe, we must also consider the environmental impact of our activities on Earth and beyond. Sustainable practices in space travel, such as minimizing waste and protecting celestial bodies, will be essential. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.